Problem 19. For this system of 4 capacitors, I have to find the equivalent capacitance of the system. As you see, first of all, I have to label each branch. Here we have A, here we have B, and between this point and this point we have nothing connected. We can say B, and here we have A. So the voltage between this point and this point equals to the voltage between this point and this point. As you see, between A and B, we have two series capacitors, and here also we have two series capacitors. I advise you to label each capacitor. Let's say we have 1, 2, 3, and 4. As you see, 1 and 2 are in series, and also 3 and 4 are in series. So we can say in this case 1 divided by C equivalent equals to 1 divided by C1 plus 1 divided by C2. So C1 2 equals to C1 C2 over C1 plus C2 equals to C1 times C2 equals to 18. Be careful here, we have micro times micro will be 10 minus 12 farad divided by C1 plus C2 equals to 9 micro farad will be 18 divided by 9 will be 2 micro farad. This is the answer of C1, C2. And the same for C3 and C4 will be 2 times, we have 2 times 4 will be 8 times 10 minus 12 farad divided by 6 times 10 minus 6 farad. We get here 8 divided by equal 4 divided by 3 micro farad. Okay, so finally we get here 2 parallel capacitors between A and B. We have C1, 2 and C3 and 4. C equivalent, which is equal C1, 2, 3, 4. In the case of a parallel capacitors, you know, C1, 2 is parallel to C3, 4. So we have to add directly C1, 2 plus 3, 4. We get 2 plus 4 divided by 3. We can say we get here 6 plus 4 equals to 10 divided by 3 microfarad. This is C total, C equivalent. Okay, we can replace this one by C equivalent. Okay. B, so I have to find the charge on each capacitors. Let me write here, you know, we calculated C equivalent. Before, as we have C equivalent, we can find Q equivalent. Okay, Q equivalent equals to C equivalent times delta V equivalent. Delta V equivalent equals to 90. Okay, so equals to 10 divided by 3 times 90. Okay, here we have, be careful the unit. We have 10 divided by 3 times 10. We can say here microfarad times delta V 90 volt. We get here 30. Here we have 30, 300 microcoulomb. This is Q equivalent. Okay. Okay, we have Q equivalent. Now part B, I want to find Q1, Q2, Q3, and Q4. First of all, you know 1 and 2 are in series, so Q1 equals to Q2, and also Q3 and Q4 are in series. We can write Q3 equals to Q4. Okay, so you know, in this case we have Q equivalent equals to 300 microcoulomb. This Q equivalent is divided between C12 and C34. Okay, the Q equivalent here we have Q equivalent divided between this part and this part. Here, as you see, Q12, if we put here C12 has Q12. Q12, as Q1 and Q2 are in series, so Q1 equals to Q2 equals to Q12, and Q3 equals to Q4 equals to Q34. Okay, and here between this point and this point we have A and B. VAB equals to 90. So we can say here delta VAB equals to 90 volt. And we have delta VAB. So we have delta VAB, we have C12, we can calculate Q12. So Q 1, 2 equals to C12 times delta V AB, okay, equals to C12. I think we calculated its value. Let me see. Equals to 2. Okay. Equals to 2 microfarad times delta VAB. You see here delta VAB equals to delta VAB. We have the same voltage between VA equals to VA and VB equals to VB, and here I take between the equivalent of C1 and C2, C12. Delta VAB equals to 90 volt. So Q12 equals to 180 microcoulomb. This is Q12. You know Q12 equals to Q1 equals to Q2. So we have C1, we have C2, we can calculate delta V1 and delta V2. Or we can follow the same procedure to calculate Q3 and Q4. Okay? Here we can say also between the point A and the point B, we have C equivalent, C3 and 4. We can say Q3 4 equivalent equals to Q3 plus Q equals to Q4 because Q3 and Q4 are in series, so they have the same Q. Okay, we have the same Q, and you know delta V 3 4 equals to delta V AB, as you see here between this point and this point, equals to 90 volt, and C3 4 equals to 4 divided by 3 microfarad. We have C, we have delta V, we can calculate Q through C 3 and 4. Q 3 and 4, okay, this one equals to C 3 4 times delta V AB, which is equal to 4 divided by 3 microfarad times delta V 90 volt. We get here 3120 microcoulomb. We calculated Q. We can, okay, here we calculated Q. So we have here Q1 equals to Q2 equals to 180 microcoulomb. We have Q3 equals to Q4 equals to 120 microcoulomb. So, you know, Q total equivalent equals to Q1, or you can say Q1, we have Q, we can say Q1 2 plus Q3 4 equals to 180 plus 120 equals to 300 microcoulomb. We calculated before. This is Q equivalent. Now I want to calculate delta V1 and delta V2. You know, delta VAB, as we have Q1 and C1 and C2 are in series, you know, delta V1, we can calculate it directly. Delta V1 equals to Q1 divided by C1. We have the value of Q1 and C1. Q1 equals to 180 microcoulomb divided by C1 equals to 3 microfarad, okay, equals to 60. We can say 60. Here we have micro and micro, we have 60 volt, okay. Delta V 2, as you know, delta VAB equals to 90. If this one has 60, so this one must have 30, okay, because the summation of delta V1 plus delta V2 equals to delta VAB equals to 90, okay. It must be 30, so equals to Q2 divided by C2. Q2 equals to 180 microcoulomb divided by C2 equals to 6 microfarad. 180 divided by 6 equals to 30 volt. Okay, this is about delta V1 and delta V2. We can follow the same procedure to calculate delta V3 and delta V4. So we can say delta V3 equals to Q3 divided by C3 equals to 120 microcoulomb divided by C3 equals to 2 microfarad equals to 120 divided by 2 equal to 60 volt. So delta V4 equals to 90 minus 60 equals to 30 volt. Okay, so we calculated the charges, all the charges and all the potential difference of the capacitors.